The powerhouse is built with heavy timbers, built to survive the shaking of the generators and the flooding of the river, and poured concrete walls go down to bedrock. The little box on the top of the roof is called a monitor. It allowed light to get into the interior, and it allowed, more importantly, heat to get out. And was a very common element in 19th and early 20th century industrial architecture, where a lot of heat and dust and smoke would be created. And just like a chimney, you need some way for it to get out. And the monitor was the way they did that. But it also creates really nice light on the inside and a more comfortable work environment. The Goldray powerhouse produced 1.5 megawatts of power. When it was first built, that was so much power they didn't quite know how they were going to use it all. Within 10 years, of course, people discovered the convenience of electricity. Copco began building other power projects, one at Prospect and the largest down on the Klamath River, both of which were significantly larger than Goldray. And they kept this one, but it really was too small to make much changes. And that's what makes it so interesting, in that essentially it's unaltered from the way it looked when it opened in 1904. It has all of its original equipment. The original twin 750 kilowatt generators are still there, and the old switchgear is all still there. And so it's really sort of a piece of time standing on the Rogue River, just as it did when Colonel Ray and Dr. Ray opened it up in 1904. It was really noisy in there. This little white building with the 5 sides is the operator's booth, and that was the 1904 equivalent of a soundproof room. These are the generators themselves, massive pieces of equipment for their time, probably got taken to the site on train and then trucked across the bridge with horse-drawn equipment. This thing that looks like a small motor is actually the exciter. It's sort of a starter motor. A small amount of water would get it started. It would produce 11 kilowatts of electricity, which was enough to kickstart the large 750 kilowatt generator. And then they didn't have to put a huge drain on the turbine immediately by kickstarting that large piece of equipment. The generator is a very heavy thing with an armature that spins at 60 cycles per second. This is the back of the switchboard. Kind of gives you an idea of state-of-the-art electric generation, 1904. The switchboard itself is all backed in marble. Marble doesn't conduct electricity, and so it was considered a safe material. And they would control the operation of these generation units matched to the spin of the turbine so that they could produce power and send it out via a transmission system. Again, the interesting thing about this is that they really never upgraded it or changed it much. 1.5 megawatts is such a small amount of power, and even was a small amount of power by 1920, that this plant wasn't worth upgrading. Copco, at various times all through the 1930s and up until the 1970s, looked at taking the old 1904 turbines out and putting in new units. And every time they did it, they decided that it wasn't economical to do so. And so the Goldray powerhouse just kind of sat there with no modification. It was producing power up until the early 1970s. Copco merged to Pacific Power in 1961. In the early 70s, Pacific Power thought about upgrading Goldray once more, again decided it wasn't economical, and ended up giving the facility, the dam, the powerhouse, and a lot of the land around it to Jackson County. There you can see, nothing much has changed since 1904. This thing here is a centrifugal pump that was connected to the generation units and created the domestic water supply at the Goldray project site. The motor would turn those serial pumps and send water up a pipe, up the hill to the storage tank at the top. This odd piece of equipment sat next to the water pump on the powerhouse floor. I spent a certain amount of time trying to figure out its function and never was able to decide what exactly it did, so its purpose is lost to the ages. This is what I guess would be called the pulley room. These are the two upper pulleys, both covered with metal protective covers, so that if a rope broke, you weren't hit with 1,600 feet of rope. This is a shaft connected to the wicket gates, which controlled the flow of water to the turbines themselves. You're now looking down into below the power floor, into the interior of the powerhouse where the lower pulleys are. Here's Unit 2's upper pulley. You can see those grooves where the rope would go. This is the stairwell down to the lower pulley area. When the plant was operational, of course, this wouldn't have been filled with water, and you would have gone down there to lubricate the lower pulleys or maintain them. They had to rebraid the rope when it broke, and it was quite an art to resplice the rope. The last operator of the plant said working at Goldray was a little bit like being a sailor. Like all early industrial facilities, the powerhouse took advantage of natural light and natural ventilation, and so it has perimeter windows around much of it and a nice monitor roof that used to have openable transom windows so that the heat that would be generated by all of this equipment could have a place to escape. Although they were powered by electricity, manpower was still pretty important, and here's a simple little winch that we don't know exactly how it was used. The rope drive, the ropes are about 1.5 inches in diameter. There would be 20 of them in series, and they would spin as a unit, much like the fan belt on your car. Here you can see the ropes through a protective screen. You definitely wouldn't want to get your finger caught in there. In the scale of electrical generation, Goldray was a pretty small plant, but when it was built, it was the state of electrical technology in 1904. This was going to create more power than had ever been created in the Rogue Valley, more power than they knew that they would ever be able to use. And it's a testament, I suppose, to the success of the electrification of the Rogue Valley that within a decade this plant had been so overwhelmed by the demands upon it that they had to build plants that were 10 times larger up at Prospect and down on the Klamath. But until Goldray started producing power, Southern Oregonians didn't really realize how convenient it was going to be to have it.